Okay, so this is 12.2b, and we are solving this differential equation using Fourier theory. Okay, and I went ahead and put the derivatives of the particular solution over here because they're the same every time, and I figured it might make more sense if you could see it outside of my chicken scratch. So hopefully that makes more sense, and they are the same every time since we're making the same base assumption that this is what the solution looks like. Your derivatives are always going to be the same. So I just went ahead and put those over there to save us all some pain and suffering. Okay, but we are going to solve this the exact same way that we solved the last one. So I'm actually going to go ahead and no. I'm actually going to go ahead and delete this line so I can get as much space as possible. Okay, so we're just going to start plugging in values. So we're starting with our y double prime. So we have our negative summation of n equals 1 to infinity of n squared, pi squared, a sub n, cosine n pi x. Okay, and then minus n equals 1, n squared, pi squared, a sub n, sine n, I don't know, I always say n and then write pi, but pi n x, okay? And now we have plus 2 times our a sub naught over 2 plus the summation n equals 1 to infinity of our particular solution up here. I'm going to try desperately to fit onto this line. A sub n cosine n pi x plus summation of n equals 1 to infinity line n pi x. Okay, and this is all equal to f of x. That's f of x in that corner. So we're just going to combine like terms now. Well, summations. We're going to combine summations that we can combine. Okay, so I'm going to start with our cosines. So the summation term's the same, which is why we can combine, which is really nice. And then over here, we have a lovely little cosine being multiplied by 2, so don't forget about that. And 2 is the only coefficient besides the a sub n, which we're going to pull out. So we're just going to put a 2 here, and then minus this little guy over here, because that is the only other coefficient besides everything that we're trying to pull out there. N pi x, so let's go ahead and do our sine terms. So very similarly, we're going to have something that looks like this, or 2 minus our n squared, pi squared, b sub n, sine pi n x. Okay, and that's the summations for our sine terms. So don't forget about your a sub 0. So the 2 and the 1/2 cancel each other out. So our a sub 0 is free. It has been freed from its fraction form. And we are going to set this equal to f of x. Well, we're not setting it equal to. We already know it's equal. That's the whole reason we did this. So now we can start actually solving for the coefficients. So let's actually start with our a sub 0. So we actually do have a lovely little constant floating out here. So we know that our a sub 0 is equal to 1/2. So a sub 0 equals 1/2. Okay, and now we have this sine term again. There are no sine terms in our driving function, so there are no sine terms here, over here. So there's nothing that's going to make this b sub n match this solution over here. So we know that our b sub n equals 0. Okay, and now all that's left is our a sub n. So again, we can cross out our cosines, we can cross out our summation, and what we're left is 2 minus n squared pi squared, a sub n equals 1 over n squared. And all we have to do is divide through by this little guy, and we'll get a sub n equals 1 over n squared 2 minus n squared pi squared. And that is our a sub n. And I did realize on the 12.2a, I forgot to rewrite our particular solution, which is very important, so please don't forget to do it. So we're going to write our particular solution with all of the proper things filled in. So for our a sub naught, we have 1/2 over 2, which is going to give us 1/4, and then plus our summation of n equals 1 to infinity. And by the way, I am comparing it to our base equation up here and just plugging in those coefficients, so don't forget about your cosine, you still need it. Of our cosine n pi x, and then divided by our n squared 2 minus n squared pi squared. Okay, and that's the whole thing, because you can plug in your b sub n, but we've already decided that it's 0, so it doesn't really matter. So please don't forget to write out your full solution, because that is what the question is asking for. So let me know if you guys have any questions on this topic or about how any of the summations work, but I'll be here if you guys have any questions.